Hi everyone. In today's lesson we'll be looking at the laws of exponents. This should be a very quick lesson because it's basically a review of your grade 9 math course. So in today's lesson, please put down in your notebook today's subtitle, Laws of Exponents. Let's take a look at the first of these laws of exponents. The first one that you studied in grade 9 was perhaps the following. Law number 1, the product of exponents with the same bases. This law looks like the following. Suppose you have base x to the power of m multiplied by the same base, x, exponent n. Do you remember what you were allowed to do with the exponents in this particular case? Good for you. If you remember that, you're allowed to add the exponents. So please, in an important color, let's get that little note down. Add exponents. And so therefore, the result of this operation would be x and then exponent m plus the exponent n. This is what's known as the product of exponents with the same bases. Keep in mind that the bases must be identical for this to work. Next, the next law that you probably ran into in grade 9 math was the following. The division of exponents with the same bases. These are the kinds of examples you ran into. Suppose I have x exponent m divided by x exponent n. And keep in mind that this may also be written with a fraction bar, x exponent m divided by x exponent n. So, what would you have done in this case? Good for you if you remember that you're allowed to subtract the exponents. So, again, with your important color, let's get that little note down. Subtract exponents. Therefore, the result of this operation gives you x to the power of exponent m subtract exponent n. Okay, let's move on. The next law that you probably ran into in grade 9 math was the following. The exponent of a product. Now this probably looked like the following. Suppose you have base x multiplied by base y, and the entire product, x times y, is being affected by an exponent m, let's say. Do you remember what you're supposed to do in this case? Good for you if you remember that the exponent impacts both of the bases individually. So again, with your important color, let's get that little note down. We distribute the exponent. That leads to a result that looks like the following. The m gets distributed to the x and gets distributed to the y. And there's our final answer. Alright, let's move on. The next law that you probably ran into in grade 9 math was the following. The exponent of a division, or in other words, a quotient, or more commonly shown as a fraction. So in grade 9, you probably encountered examples that look like this. X over y. Remember, x is a numerator, y is a denominator. And all that exponent, let's say m. Do you remember what you're supposed to do in this case? Good for you if you remember that the exponent m gets distributed to the numerator and the denominator individually. As usual, take your important color and let's put that little note down. We distribute the exponent. This gives us a result that perhaps looks like this. X to the power of m over y to the power of m. And finally, the last law that you probably ran into in grade 9 math was the following. The exponent of an exponent. And this means the following. The most basic example would be, suppose I had x to the power of m and that entire thing to the power of n. Do you remember what you're supposed to do in this case? Good for you if you remember that the exponent outside of the bracket gets distributed to each individual item in the bracket and you multiply the exponents together. Again, with your important color, please get the following in your notebook. We distribute and multiply the exponents. So in our example, our final result is the following. X m multiplied by n. Let's take a look at another example of this law using a more significant expression inside the bracket. How about if we had x to the power of m, y to the power of n, and outside the bracket everything is exponent, let's say the letter b. Well, as the rule states, we have to distribute the exponent b to the x and to the y individually, while at the same time multiplying the exponents. So this will result in x to the power of m times b and y to the power of n times b. And that completes all the 5 laws that you first saw in grade 9 math. I would like to now continue on by paying particular attention to a couple special cases and dangerous scenarios. So in your notebook, please put down special cases. Now there are 2 special cases I'd like to look at. So for the first one, please put a 1 in a circle. And I'm pretty sure all of you know this case by now. It's what happens when something is exponent 0. Everyone knows this. Anything to the power of 0 simply equals 1. I don't care if it's x to the power of 0, z to the power of 0, or 9 million to the power of 0. Anything to the power of 0 is equal to 1. And the second special case is extremely important. So put 2 in a circle. And this second case involves how do you turn a negative exponent into a positive one. I'm sure that in grade 9 you've spent a significant amount of time practicing this. Well, suppose that we had x to the power of negative m. If you remember your math correctly, to turn the exponent negative m into a positive m, you would have to take the x, and if it's in the numerator position, which it is right now, you switch it to the denominator position. So this becomes 1 over x, and the negative m becomes positive m. Or, if your exponent already started in the denominator position, so let's say we have 1 over x to the negative m, then we have to switch it to the numerator position. So this goes into the top here, and the negative m becomes a positive m. And finally, as promised, I would like to look at a couple of dangerous areas. So in your notebook, I want this whole section written in your danger color. For me, that'll always be red. I'd like you to put down dangers. The first danger I want to look at is the following. So please put number 1. It's what happens when you have the following. In a bracket, you don't have a product, but you have an addition, x plus y, let's say. And outside the bracket, you have exponent, let's say m. You might tend to think that you distribute the m to the x and to the y, but actually you don't. In fact, x plus y all to the power of m does not equal to x to the m plus y to the n. There is no specific rule or law that allows you to do this. Please note that this law applies to subtraction as well. So if you want, you could put it down in your notebook. Or x subtract y all to the power of m does not equal x to the power of m subtract y to the power of m. The second danger is the following, and this is a danger that you've been dealing with since grade 8. So please put number 2. It involves negative bases with exponents. Something like this, negative 3 to the power of 2. Well, as you can see, there is no bracket surrounding the negative 3. So the exponent 2 affects only the 3 and not the negative. And this makes it different from the following. In the second case, the negative 3 is surrounded in the bracket, and therefore the exponent 2 affects the 3 and the negative sign. In fact, operationally, it looks like this. In fact, the negative 3 squared operationally means the negative of, and brackets, 3 times 3. Because remember, according to BEDMAS, the exponents are done before multiplication. And this results in negative 9. On the right side, the negative 3 all exponent 2 operationally, in fact, is negative 3 times negative 3. And this, in fact, gives positive 9. As you can see, they are not equal. And this, ladies and gentlemen, completes our review of grade 9 laws of exponents. As you can see, the laws have not changed regardless of whether you're in grade 10 or in grade 11.